Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, lesson 2, the height and Kohite functions of a Ferris wheel. Classwork opening exercise. Suppose a Ferris wheel has a radius of 50 feet. All right, so they've graphed it here for us. Here's a circle centered at 0, radius 50 feet, 50 feet, 50 feet, 50 feet. We will measure the height of a passenger car that starts in the 3 o'clock position. They've already put a dot there, 3 o'clock. With respect to the horizontal line through the center of the wheel, which happens to be our x-axis. That is, we consider the height of the passenger car at the outset of the problem, that is, after a 0-degree rotation, to be 0 feet. Mark the diagram to show the position of a passenger car at 30-degree intervals as it rotates counterclockwise around the Ferris wheel. So we're going counterclockwise. We're going to go this way. All right, so I'm going to get my compass. My compass. This is not a compass. You knew that, right? This is a protractor. I brought my protractor. Okay, so there's my protractor. Crosshairs right at the origin. And I want a 30-degree interval. So that would be right here. Okay, right out there. So if I shrink this down now so I can't read it, then I can put my intervals. So this was 15, here is 30. It's hard to see, but that is 30. So I'll put a dot right there. There's 30. 45, 40's here. That is hard to read. What are we going in? 15, 40, 50. So we want 30, we want 60, we want 90. So 60's right here. That would be on the circle right there. It won't let me draw there. There we go. There's 60. Obviously 90's here. 90. How many degrees are they going in? I can't even read it. 10. Okay, so that's 100. Here's 100, here's 110. 90, 110, 115 is right here. 120, 125, 130, 135, 140, no, that's not right. What am I doing? 140. All right, so here we go. $30 degrees is right here. So I missed the 30. It's 10, 20, 30. So they're going in tens. So let me put a dot there. Let me erase this one. All right, so 30, 60, 90. Okay, and I want another 30, which would be 120. Okay, 120, 150. Shrink that down a little. 180. Let me rotate it and repeat. So 10, 20, 30 would be right here. 40, 50, 60 is right here. 70, 80, 90. 3 more. 1, 2, 3 more. And then we're back to 0. So there it is. So this is 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210, 240, 270, 300, 330, and 360 brings us back to 0. So I'll put 0 degrees, comma, 360 degrees. Okay, so there we go. That's part A, marking the diagram. Part B says, sketch the graph of the height of the function of the passenger car for 1 turn of the wheel. Provide appropriate labels on the axes. Okay, so providing appropriate labels on the axes, amount of rotation degrees. Okay, so this axis here is rotation in degrees. And the x-axis is height in feet. Okay, height in feet. All right, so now I'm going to graph this. So at 0, we're at 0 degrees, right here. At 30, we were around 25. So I'll put a dot somewhere around here. At 60, we were around 45. And at 90, we were about to 50. Okay, and what's nice about this is they repeat coming back down. So this height would be the same. So 120 is the same height as 60. 150 is the same height as 30. So that's going to go here. And then 180, we are back to 0. Okay, so there's our curve right there. And now we're going to go negative. Now we're going to go down to negative 25 approximately for 210. 240 degrees is going to be below 40, somewhere down here. And then the maximum 270, minimum, I should say, is negative 50. And then again, these repeat and back. So there it is. I'm not going to try drawing this. You can see the sine curve. It's sinusoidal. Okay. All right. So there it is, graphed with appropriate labels. Okay, page 2. Part C says to explain how you can identify the radius of the wheel from the graph in part B. Okay. So the graph of the height of the function for one complete turn shows a maximum height of 50 feet and a minimum height of negative 50 feet, suggesting that the wheel's diameter is 100 and thus its radius is 50. So let's go back and look at that. So the maximum here is here and the minimum is here. So our range is a distance of 100 feet and that would be the diameter. So the radius is half. Okay, so part D says if the center of the wheel is 55 feet above the ground, how high is the passenger car above the ground when it is at the top of the wheel? So you would have center plus radius equals maximum height. Think of it that way. So if the center of the wheel is 55 feet and the radius is 50 feet, then the maximum height is 110 feet. Okay, I can't add. 55 plus 50 is not 110. Ay caramba. 55 plus 50 is 105 feet. Okay, so anywho, exercises 1 through 3, each point 1, point 2, point 3, P4, P5, P sub 6, P sub 7, P sub 8. On the circle in the diagram to the right represents a passenger car on the Ferris wheel. Okay, so they're either not separated with the same distance between each, or we're not counting other ones that are there. It says draw segments that represent the Kohheit of each car. Which cars have positive Koheits and which cars have negative Koheits. Okay, so that's a new term for you, Kohlheit. So let me explain what Kohlheit is. So let me draw some lines. So if I drew a line from the center of the circle out to P sub 1, okay, that is our radius. All right. And then if I drew a line segment over to the y-axis, perpendicular to the y-axis, parallel to the x-axis, and then if I drew a straight line down and created this rectangle, okay, we now have this is my Kohheit, and this is my height. Okay, so the height is the vertical height, the Kohheit is the horizontal height, if you will, the distance from the y-axis or the center out. Okay, and this creates an angle of theta degrees. Okay, so that's height and Koheit. So it says draw segments that represent Koheit of each car. Which car has a positive Koheit and which car have negative Koheits? Okay, so now I'm just going to draw all these Koheits. I'll just use this tool here, and thin and red. And so here is car 2. So my Koheit's right there. Here's car 3. There's its Koheit. It's got to be perpendicular to the y-axis. So I'm just drawing these Koheits out like so. P3. Okay, so basically it's pretty simple. Koheit is the distance of a point to the y-axis. Oops. Okay, so there are all of our Koheits for P1 through P8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so, well, positive Koheits, that means when we're going to the right is positive and going to the left is negative. So this is 0, 0, here's -1, -2, -3, and so on. So any Koheit to the right of this axis is positive. So positive Koheits and negative Koheits. Okay, so I'm just going to do a table here. So the positive Koheits are P sub 1, P sub 2, P sub 3 is on the left side of this, so this goes over here. P sub 4 is negative. P sub 5 is negative. And P sub 6 is negative. Then we go back to positive. P sub 7 is positive, and P sub 8 is also positive. Okay, so let's just pause here for a second. And if I were to graph this, going over here, x distance is our Koheit. So the x value is the Koheit. And the y value is the height. Okay, so think of it that way, x comma y, Koheit comma height. Koheit is just our x values, height is our y values. So that makes it a lot easier when you're thinking about this. And then part B says, list the points in order of increasing Koheit. That is, list the point with the smallest Koheit first, then the point with the largest Koheit last. Well, the smallest is the furthest left. So the furthest left is going to be P5. So we're just listing these from least to greatest, most negative to most positive. So P sub 5, so I'm right here. So if I go this way and I look up or down, P sub 4 is the next one. And so now I'm here. And if I continue this way, P sub 3 is the next negative number that I reached. And if I'm moving to the right on the x-axis, now I'm at P sub 6. And we just keep going to the right. And if I cross now, and now I'm at P sub 2, which is right here, that's P sub 2. And the numbers are getting larger as I go this way, and there's P sub 7. And then finally P sub 1. And lastly, P sub 8 is the largest positive Koheit. So there they are, 5, 4, 3, 6, 2, 7, 1, 8. Okay, page 2. Suppose that the radius of the Ferris wheel is 100 feet. Okay, the radius is 100 feet. And the wheel rotates counterclockwise through one turn. Define a function that measures the Koheit of a passenger car as a function of degrees. So as a function of the degrees of rotation from the initial 3 o'clock position. Okay, so we're starting at 3 o'clock. So there's a lot of highlighting there, a lot of information there. Okay, radius of 100 degrees, rotating counterclockwise, one full rotation. And we're going to define a function that measures the Koheit. All right, so if I go back to this circle here, we are measuring in theta degrees. We're measuring in degrees going counterclockwise. So we're going this way. So here is 0 degrees. And this was, remember when we did the other one, 30 degrees, 60 degrees, 90 degrees. Okay, that is going to be our X values, going over 0 degrees, going over 30 degrees, going over 30 or 60 degrees. And what's the height in feet? So our X is going to be degrees and our Y is going to be feet. So I'm going to just put that over here. X is going to be degrees and Y is going to be feet. Just to keep this straight. So what is the domain of the Kohite function? Kohite being X. Well, the domain is, we're going to start at 0 degrees. And we're doing one turn. So we go 0 all the way around 270, all the way around to 360 degrees, including. So whenever we include, we use brackets. So the domain is 0 to 360 inclusive is what you say. Okay. And then it says, what is the range of the Kohite function? Well, keep in mind that we're measuring in feet. And the radius is 100. So we're starting at 0. So let me go back to the circle here. So we are starting at 0 feet, and up here is 100 feet, and down here is negative 100 feet. So our range is from negative 100 to 100. So our range is negative 100 to positive 100 feet. Okay, part C says, how does changing the wheel's radius affect the domain and range of the Kohite function? Okay, well, the domain is in degrees. And no matter how big or small we make a circle, one full rotation is always 360 degrees. So the domain remains the same. Okay, and the range, if we change the radius, the range is maximum, minimum, increase or decrease. So the range, how could we say this? Range of the Kohite depends on the radius. So the range of the Kohite function is whatever the radius is, negative, comma, positive. Okay, and if I go back and show that, this is a radius of 50 here. Well, let me go back down here where where am I? Right here. So it would be a radius of 100. If I put this as 100, negative 100, the radius is 100. So we went to the positive radius and the negative of the radius. If I change that to 200, my maximum would be 200, my minimum would be negative 200. So it's the positive and negative radius, and that is our range. Number 3 says, for a Ferris wheel of radius 100 feet, going through one turn, how do the domain and range of the height function compare to the domain and range of the Kohite function? And is this true for any Ferris wheel? Okay, so the domain for each function is 0 to 360 inclusive. That never changes, where rotations are measured in degrees. The range of each function is negative 100 to 100, that's feet, for any Ferris wheel. The domain of the height and Kohite function is 0, 360. The range depends on the radius r of the wheel, but for both height and Kohite functions, the range is negative r to r, the radius. Thus, the height and Kohite functions for a Ferris wheel have the same domain and range. Okay, page 4 brings us to an exploratory challenge. And it's the paper plate model revisited. So it says to use a paper plate mounted on a sheet of paper to model a Ferris wheel, as shown, where the lower edge of the paper represents the ground. Use a ruler and protractor to measure the height and Kohite of a Ferris wheel car at various amounts of rotation. measured with respect to the horizontal and vertical lines through the center of the wheel. Suppose that your friends board the Ferris wheel near the end of the boarding period, and the ride begins when their car is at 3 o'clock position as shown, which is this dot right here. And he says to mark the horizontal and vertical lines through the center of the wheel on a cardstock behind the plate as shown. We will measure the height and Kohheit as the displacement from the horizontal and vertical lines through the center of the plate. So B says, using the physical model you created with your group, record your measurements in the table and then graph each of the two sets of ordered pairs, rotation angle height and rotation angle Kohheit, on separate coordinate grids. Provide appropriate labels on the axes. So I've taken this circle and I've copied the lines from the last lesson over. It was just easier. And these lines are every 15 degrees. So this is 15 degrees, 30, 45, 60, 75, 90. Why did I go 15 degrees? Because the tables did. So I'm using their values, and that's what I created here. I also drew the horizontal and vertical lines to find the center of the circle, so it makes measuring easier. Okay, because it's kind of, all those lines kind of create a blotch in the center. It'd be better on paper with a fine pencil, but anywho. So now we're going to do this, and the height, remember, is vertical and the Kohheit is horizontal. So I really wish they would have reversed these, because we usually do tables X, Y, not Y, X, but they're labeled correctly. So I guess it's not incorrect, but I prefer Kohheit to be my first. So now I need to take the time to measure these. So I put my ruler right there at the origin being 0, and I come out and that is 2.6 centimeters. So that is the horizontal distance. It is 0, it's in centimeters, not degrees. So that would be 0 degrees, but they want it in centimeters, and that would be X, which is 2.6. See, this is confusing. I usually put my X here and my Y here, reversed. This would be X comma Y, but anyhow. So the 2.6 is the Kohheit. We're going to call this 0 for the height in centimeters. Okay. Then I'm just going to move my ruler. I wish I could just use my arrows, but it doesn't allow me. Trying to move this straight up. See how it moves when I move my pen. Okay, so there's 0 there. And this distance now to this point here looks like 2.1234. So now we're at 2.4 centimeters. I'm doing Kohheit first, X. And then if I move the ruler straight up to here and put it on 0, and then I measure over, that's 2.2. Keep going, 45 degrees. Now, keep in mind, a circle repeats every quarter. The height, this height is going to equal this height. This height is going to equal this height. This height will equal this height, and so on. And if you did it correctly, the reverse, this height here would be equal to this negative height here. So once I get up to 90 degrees, I can just repeat the whole table without having to measure. So you really only have to measure 1, 2, 3, 4, 5, 6. Okay, and we're done. Okay, so we're half done already. So, and if I move this up now, we are at 45 degrees, and I put the 0 right on the line, like so. This is 1.567. That looks like 1.8. And then if I move up to the next one, which is 60 degrees, that is 1.12. This is that right? No, it's 1.2. Was that 1.8? No, it's 1.543. Let me measure this one again. Seems like too much. Oh, that's 1.8. My values might be off a little bit when I drew these. Okay, so that looks like 1.3 3. And then finally, 75 degrees is right here. And that looks like not quite. That looks like 0.5. Point 6. 0.6. Okay, so as I'm saying now, the 0 now is actually going to be 0. The Kohheit when you're on the y-axis is 0. So that's 0. So when down here is 270, 270 is going to be 0. The computer just froze. Let's try that again. 0. Okay. So what I mean now is this height should be the same, this distance to the right should be the same distance to the left, but only negative. So if this one was 0.6, this should be negative 0.6. And then this one comes down negative 1.3, negative 1.8, negative 2.2, negative 2.4, negative 2.6. And then it repeats. So now this is negative 2.6. This was negative 2.4. So this should be a negative 2.4. And then negative 2.2, and then negative 1.8, and then negative 1.3, and then a negative 0.6, and then getting back to 0. All right, so then 285, here's 270, 285 is here. It should be the same as this, but it's positive. So that's going to be 0.6, 1.3, 2.2, 2.4, 2.6, and 0. No, what did I do wrong? 0, negative 0.6, 1.3. I missed 1.8. All right, so let me erase this. I missed my 1.8, 1.3, 1.8, 2.2, 2.4, and then back to 2.6 at 360 degrees. Okay, so there is our table. And now I need to do 6 of them for the height, which is my y value, height 0 centimeters. And then I just come over here and now I'm measuring how far they are from the x-axis. And that looks like 0.5 or 6. I want to get that. No, I guess it is 0.6. Okay, so that is going to be 0.6. And again, we only need to do 6 of these. Looks like 1.2. This is 1.7. Actually, it's more like 1.8 because we're at 45 degrees. The x and the y should be equal. 1.8. This is 2.2. Okay, and I'm thinking about something here, so I'm going to get back to that in a second. And that looks like 2.4. And then 90 degrees should be the same. This distance should be the same as this because that's our radius, and that should be 2.6. So I'm not even going to measure it. So now look at my values. I have 0, I have 0, 0.6, 0.6. Let's change this to 1.3. Because we're leading up to something here. 1.3 at 30 degrees and 60 degrees, your x should equal your y. Okay, and then 1.8, 1.8, 45, the x and y should be equal. 2.2, 2.2, 2.4, 2.4, 2.6, 2.6. Okay, so now we're just going to repeat. We got all the way to 2.6, and now we're going to decrease again. 2.4, 2.2, 1.8, 1.3, 0.6, 0, and then we're going to repeat again, and now they're negatives because we went on the positive side of the x-axis. Now we're down to the negative side, so it's negative 0.6, negative 1.3, negative 1.8, negative 2.2, negative 2.4, and 270 would be negative 2.6, our radius negative. And now we're going to decrease again to negative 2.4, negative 2.2, negative 1.8, negative 1.3, negative 0.6, and 0. Okay, so there is the domain and range set up for this circle based on feet, not degrees. Okay, page 5 brings us to the page where we have to graph our data. So I have the data on my other screen here. I made a copy. So I'll be looking over here and doing this, and you'll have to go back a page and forward and so on. So here we go. All right, so let's use red. Height as a function of degrees of rotation, Koheit as a function of degrees of rotation. So rotation degrees is going to be x. Oh, okay, so height and Koheit didn't really matter over there. It's not x, y, it's, well, it kind of was, but anyhow. Now x is our rotation degrees. Okay, so this is rotation in degrees. So I'm going to write that. Rotation in degrees. Okay, you always label your x and y axis. And we're measuring height as a function of degrees of rotation. So this over here is going to be height in centimeters. Okay, so there's our axes labeled. And now I'm looking at rotation degrees and height. So that's going to be 0, 0 was what we had. Now yours is going to be different if you did this on a plate or even in your book. 15 degrees, I got 0.6. And so now, of course, this is going up to 20 because they were using a paper plate. So I need to change these. My maximum was 2.6. So how do I do that? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 grids. So 2.6 divided by 10 is 0.26 each one. And that's just a little bit too tough to do. So how about, let's see, if I want 2.6, here's 1, here's 2, here's 3, 1/2, 1, 1.5, 2, 2.5, 2.5 is here. So that's what I'll do. So this will be 1/2 centimeter. Let's use decimals, 0.5. This will be 0.5. This will be 1. This will be 1.5. This is just for my video. This will be 2, and this will be 2.5. So I need to change my height, but my rotation in degrees is always going to be 0 to 360. So there we go. So now we have the point 0, 0, and now we have the point 15 degrees, 0.6, which is just above 0.5. This would be 0.75 and 1. Okay. 30 was 1.3. 1.5 is here, 1.25, so it's just above the halfway there. There's 1.3, and 60 was 1.8, 1.5, 1.75, 1.8 would be about there, and 60, my maximum. I'm going in 15 degree increments, so that's got to be moved over here. Okay. At 60, 2.2. So here's 2, 2.25 just below. And 75 is 2.4. So here's 2.5, so just below 2.5, 2.4. And finally, 90 is at 2.6, which is just above the 2.5. Okay, so the hardest part is just getting started. Now I just copy the one over. Same height on the other side of my maximum. So this will be here. And this one will be here, and this one will be here. You get the idea? And the next one will be down here. and finally back to 0 at 180 is 0. I did something wrong here. This should be here. And this, where's my point for 1? 15.6. 0, 180.6. So this should not be here. Okay, these are all messed up. I see where I did now. This has to go here. This one over 1, I didn't go over 1. This one should be here, not here. All right, now we got it. And this should be here, and then finally there. So there's my curve. You can see it curving up, coming back down. And then what's it do? Then after 180, we got to 195, which is 195 comma negative 0.6. So let's change my scale here. Negative 0.5, negative 1, negative 1.5, negative 2, negative 2.5. So disregard these values for the video. All right, so now negative 0.6. Let's move this rotation in degrees closer so I can plot. And negative 0.6 at 175 is right about here. And then negative 1.3, wait, where was I? All right, negative 0.6, negative 1.3, negative 1.3, here's 1.25, 1.3 is about there. That's 210, 225, negative 1.8, 225, negative 1.8, right about here, 240, negative 2.2, right about here, negative 265, or 265, 255, negative 2.4, and 270, 0. 270, negative 2.6, right here. And now these are going to repeat for height. This one's going to go over here. This one's the same height at this level. This one's over here. This one repeats here. And finally, 360 back to 0. So you can see the nice sine curve going down and then up, or up, down, and then back up at our maximum 2.5 to negative 2.5. So that would have been the diameter of my plate on the paper was a diameter of 5 centimeters. Okay, so now we're going to graph the Kohheit function degrees. All right, so we're going to do the same thing. We're not using these values. We're going to use 2.5. Not 2.5, that's the top. 2.5, 2, 1.5, 1, 0.5, 0, negative 0.5, 1, 1.5, 2, 2.5, and this was height in centimeters. This will be Kohheit in centimeters. And this is going to be rotation in degrees. Okay, let me just move this a little closer, and here we go. All right, so now I'm graphing the rotation degrees, comma, Kohheit. So at 0 degrees, we were at 2.6, which is here. At 15 degrees, we were at 2.4, which is about here. At 30 degrees, we were at 2.2. At 45 degrees, we were at 1.8. Right about here. That's 1.75, a little higher. At 60 degrees, we're at 1.3. Here's 1.5. Here's 1.25, 1.3 would be about here. Okay, and then 0.6 at 75, we're at 0.6, which is just a little above 0.5. And at 90 degrees, we're at 2.6 comma 0. 90 degrees 0, I mean, 90, 0. So there it is coming down to 0. Continuing, we then go to 1.8. Let me make sure I got this right. 90 degrees, after 90 degrees, 105, negative 0.6, which is here. Okay. And then 120 is negative 1.3, which is here. 135 is a negative 1.8. 135, negative 1.8 is about here. 150, negative 2.2. Or 165, negative 2.4. And 180, negative 2.6. I'm just verifying that. Okay, so there it is. So what's nice now is from here back up to 270, these values are going to repeat. So I'll put a dot here and go over 1 and come to this height here, right there. It just is quicker this way. Okay, did I do that right? No. So I need to move these over. 270, not 240. This would be here, right here. Okay, that's better. And then this one will go here and this one here. So it's a nice smooth curve curving back up, coming to 270. Now what's nice about this, I don't have to look at my graph anymore. It's repeating. This height over here will equal this height right there. This one will come all the way over to here and continuing up. So once you get half of it done, the rest is pretty much smooth sailing. Okay, and then finally our max right there. Okay, so something really interesting occurred there. All right, so this is a curve, a sine curve. Sine goes from 0 up to a maximum, back down to 0 at 180, decreases to a minimum at 270, and increases back to 360 and 0. Okay, that is a sine curve. Okay, this one, starting at the maximum, coming down to 0, and then down to the minimum and back up, is really this function shifted 90 degrees to the left. So if I move this whole graph right here over 90 degrees, it would match this with this piece cut off, of course, and then repeating over here. This is a cosine function. All right. Okay, so let's wrap this up in the closing. So it says, why do you think we named the new function the Kohheit? Okay. All right, so both functions measure a distance from the passenger car to one of the axes at various numbers of degrees of rotation by the wheel. So the horizontal measurements are closely related to the vertical measurements. The next one says, how are the graphs of these two functions alike and how are they different? Okay, so I kind of already mentioned that, but let's put it into words. Let me grab it here. Okay, so the graph of the Kohheit function appears to be a horizontal translation of the graph of the height function. So I mentioned that it was shifted to the left by a distance of 90 or by 90 degrees. Okay, assuming we create both functions from the same initial passenger car position on the same Ferris wheel, the two functions will have the same domain and the same range, but the values of the functions are not the same for the same amount of rotation. When one function has a value of 0, the other has either a maximum value of 1 or a minimum value of -1. Okay, so then it says, what does a negative value of the height function tell us about the location of the passenger car at various positions around the Ferris wheel? And what about the negative values of the Koheit function? Okay, so let me bring those in and we'll be done. All right, the negative values of the height function tell us the passenger car is below the center of the Ferris wheel. The negative value of the Koheit function tells us the passenger car is to the left of the center of the Ferris wheel. And there you have it. Okay, page 7 brings us to the end of lesson 2. Go to your problem set.